right, we're going to get started today with practice exercise number 66. Practice exercise number 66.
Love doing business with Mr. Agassi.
Practice exercise number 66. Practicing with finding the mean. Remember that mean simply means, class, average. Mean means average. So to average things, you simply add them all up and then divide by how many there are. Exercise 66, you may begin. Let's go ahead and take a look at these. And Genesis was first. Genesis, as we go across the top row, what did you get for your answers?
58.
Correct.
141.
Good.
199.25.
Good. 58, 141, and 199.25, or 199 and 1/4. All right, going across the bottom row.
690.
Correct.
8.2.
Yep.
24.2.
Got them all. Excellent job. Again, 690, 8.2, and 24.2. A couple things before I collect these from you. First of all, as you look at your answer, you'd want to make sure it looks right. For instance, if on the very first one on the bottom row, I had an answer of like 1,000 something, would that make any sense? No. How could the average be bigger than the other numbers? Or if I had a number like 500, seems a little low, doesn't it? I mean, considering I got 900, 700, and I did have a 400, but 500 still seems pretty low. So again, using some common sense to make sure your numbers are correct. Why might you get the wrong answer like that? What might you do that would throw your answer off to where it would seem wrong?
You can forget to clear. You can multiply when you're supposed to divide.
Right, you certainly could hit a wrong button. I would say that's a possibility.
You can divide by the wrong number.
Dividing by the wrong number is perhaps the most common thing, right? You count up and you're like, okay, divide by 7. Oh, there's 8 numbers there. Oops. Or divide by 9, but there were 8 numbers there. There is a way, though, for those who have a calculator like this one, I'm not sure about other calculators necessarily, but the TI-30XA, there is a feature that takes the guesswork out of dividing. You don't even have to do the dividing. You can use something called the statistical mode of your calculator. On your calculator, I want you to look above, those who have a calculator like mine, the rest of you, I don't know that you would have this feature, but above your x squared button, you'll see a mathematical notation, x bar. This is a mathematical symbol for the mean. Now, those who had me in Algebra 2 last year, you'll probably remember this X bar notation. Refers to the mean. You also see a button right above, or right here on the left-hand side, sigma plus. That button would allow you basically to put in various values. So those who have a calculator like mine, again, I apologize to the rest of you. Let's go ahead and look at the next to last problem. Start by putting in a 15, and then hit the sigma plus key. Now you'll notice your calculator suddenly does several weird things. It now says n equals 1. It's telling you how many items you've put in. It also has a little word stat at the top, meaning your calculator just went into statistics mode. And of course, mean would be a statistical function. Don't worry about it. Then hit 9 sigma plus. It now tells you have 2 numbers you've entered. That's okay. Now hit 7 sigma plus. 6 sigma plus, 8 sigma plus, 11 sigma plus, 4 sigma plus, 9 sigma plus, 6 sigma plus, and 7 sigma plus. Now, in case you needed it, it's telling you just put in 10 numbers, but you don't even need to know that because you're not going to divide by 10. You're simply going to use the second function of your calculator and hit that X bar, second function X bar, and it'll give you your average. If you wanted to know, well, what would it have been if I'd added them all together? Right below that, you see the symbol sigma x. This means the sum of all the x values. Well, second function sigma x tells you it adds up to 82, which makes sense. 10 numbers, the sum is 82. That would be 8.2. If you wanted to know the sum of all the squares. Now, for those who haven't had Algebra 2 yet, you're like, why would I want to know the sum of the squares? But those who had Algebra 2 last year, do you remember talking about mean deviation, standard deviation, where you would have to use that variance idea that uses squares? Well, the sum of all the squares, the sum of 15 squared, 9 squared, 7 squared, 6 squared, 8 squared, 11 squared, 4 squared, 9 squared, 6 squared, and 7 squared. Well, that would be sum of sigma x squared. Just in case you're curious, what is the sum of all those squares added together, Quentin? 758. For those who remember standard deviation, you'll remember that's lowercase sigma xn minus 1. Well, that's above your square root symbol. The standard deviation for this set of stats would be 3.08. So again, your calculator can do a lot of these things for you. Now, I'll tell you where this personally helps me. This, not so much all the other little numbers I just went through, but the sigma plus, sigma plus, sigma plus, and then the x bar. Years ago when I taught 8th grade and we had a whole bunch of speed drills. How many here in junior high remember the speed drills? Okay. Well, the problem is we might do a bunch of speed drills, and if you were here every single day, you might have 15 speed drills. Divide by 15. But then if Ethan's gone a couple of days, maybe he's on a basketball trip, so he misses a couple days. Well, I'd have to divide his by 13. Well, what if I divided by 15? Now instead of having a 92 average, he has a 71 average. Stinks to be Ethan, doesn't it? Well, no, because instead of dividing by 15 on all of them, instead of adding them and dividing by 15 out of habit, I just used that X bar. I didn't have to worry about how many to divide by, or if Quentin was out for a day, or Kendall. It doesn't really matter, right? You just X bar, and it takes care of the averaging for you. So just a little feature that's on some calculators, including the TI-30XA. Yes, sir?
Did you use that example because it actually happened?
Well, Ethan, not necessarily specifically, but, and again, I used the X bar because I knew it could happen. I didn't want to risk messing up someone's average. All right, any questions on the practice exercise? All right, go ahead and pass those forward if you would. Please just get out some blank paper, maybe a couple sheets of paper. We're going to practice some constructions before we get into the last 2 constructions in this latest round. Get out some blank paper, and if you would, go ahead and draw a circle on your paper. Make it not too big, maybe an inch or so in radius. An inch or so in radius. And as we did yesterday, go ahead and mark the center point. Since we're lazy and would rather not have to find the center point, not that we couldn't if we wanted to, right? Practiced yesterday finding that center point if we should ever need it, but we'll label the center point, and then I want you to pick a point maybe around 5 o'clock. We want to put a tangent on that point. We want to put a tangent at that point, what would I need to do? Walk me through putting a tangent or constructing a tangent to the circle at this point. Jamie?
A tangent, you would first make a radius.
Okay.
Would you go through the point?
Good. When you make the radius, go ahead and extend it through the point a little bit. All right. Let's see. Then what would I need to do? Quentin?
You would measure half of the radius.
Okay, I could measure half the radius. You don't necessarily have to measure half, but open the compass up so it's not real big. Right?
Make a mark above and below.
Make a mark above and below the line, like this. Oh, above and below the point, on the line. Okay, I'm sorry. Yeah, since we're at 5 o'clock, above and below would kind of be, I'm looking at it sideways here, standing next to it, but you're right, above and below would be still on the line. Okay, so make marks on either side of the point on that line. And then what would I need to do? Ethan? Help him out. Kendall.
Point on the compass and the intersections.
Okay.
And open your finger. And you make arc.
And then go make an arc somewhere out here. And you said intersections because you'll go to the other one also and make that same intersecting arc. And then, Ethan, you can simply connect the dots. And there we go. That was construction 14A from yesterday. Any questions on this construction? All right, if you would now draw another circle. Make it rather small this time. Open your compass up. I mean, so that it's comfortable. Not so small it's not even comfortable, but don't open it very big. Make a small little, oop, try to keep the point of the compass from slipping. And again, mark your center. I'm going to pick a point down a good distance underneath. I'm going to pick a point a good distance underneath my circle. So go down a little ways below it. I want to construct two tangents to the circle. Two tangents to the circle from this point. Now again, one could almost make the argument that with a straight edge, you can kind of eyeball it. Like here, no, here, no, here, no, here. Looks like right there-ish. But to construct it means we know for sure we nailed it exactly right. So rather than just eyeballing it and giving it a guess, which wouldn't get you any points on a construction quiz, let's go ahead and go through the steps here. And Chris, what do we do first?
This is construction 13.
We're constructing two tangents from this point to the circle.
Okay.
We make it an ice cream cone.
Make a big radius.
Make a big radius?
Yes.
To
the point.
Okay, so actually just connect the dots to start out with, right?
Except
So
extend a little bit further past the point.
we don't even need to extend it past this point. We're just going to go straight to the point. Just join the points. Just join the points. Then what should I do? Audrey? Bless you. We need to find the midpoint. How do I find the midpoint of that line? Good, we're going to construct the perpendicular bisector of the line. So again, open that compass more than half. Arc to one side, arc to the other, go up top, to the center, arc to one side, arc to the other. And again, as a line, this is relatively meaningless. Though it does begin to look a little bit like we're playing hangman. But really all I care about is this one point, the midpoint. Just put two legs on him and all right, all right, then what do I need to do next? Jamie?
Would you put the point of compass on the center?
I could. I normally put it on the midpoint. But it wouldn't necessarily be wrong to put on the center, just make an extra step in a minute. But what do we want to do with our compass?
We want to connect it to the center.
We want to measure the half, right? We just found the midpoint to get two halves. We want to measure the half, which is why I said you could technically put it on the center. You'd still be able to measure that half, wouldn't you? But I normally want to put it on the midpoint so that once I've measured the half, Genesis, once I've got this halfway measurement here,
You do arcs of
Ethan?
Continue.
Good, I would make an arc. So I'd measure the half, and while I'm right here, go ahead and make the arcs through. You can make one continuous arc, or you can just make these little pieces there to get those 2 points of tangency. So now it's a man who's frowning about being hung in Hangman, all right, with a long mustache too. And now to finish it out, class. By dots, of course, we mean these two dots need to be connected to the original given point that was down here. And now instead of a man in Hangman, it's beginning to look a little bit more like the ice cream cone. I dropped something, yes.
Could be like that.
All right. Questions on this? Questions on this? I seem a little shaky with our memory on it here. That's okay, that's why we practice. All right. If you would now go ahead and on your paper, maybe turn the paper over at this point if you haven't already, and draw a triangle. Make it a good sized triangle.
Do you care acute or obtuse?
Doesn't really matter, no. Either is fine. So draw a triangle. Make it a good size, though. If you want to, you can even make a right triangle, I suppose. I don't think we've done one of these yet.
That'd be kind of a weirdo, but
I'm doing a right triangle.
All right, as soon as you mentioned weird, Ethan's all in. All right, so let's go with...
so is Mr. Midhafty.
I am too. All right, we'll make a right triangle. All right, and we want to inscribe a circle inside our triangle. We have circumscribed a circle before. If I wanted to circumscribe, and I don't, but if I wanted to circumscribe a circle here, what would I need to start with, class?
Making the perpendicular.
Perpendicular bisectors. But if I want to inscribe the circle, I need to start with angle bisectors. Good. So let's start with a couple of angle bisectors here. When you get a lot of arcs right in the same spot, it can start to get a little confusing. So, again, erasing some of the extra arc isn't a bad idea. And again, a third angle bisector would help, though it's not necessary per se. 2 is technically enough, though practically. And you can see if you look closely, my 3 angle bisectors didn't quite hit perfectly, did they? Got a tiny little triangle formed by those 3 lines. I'm just going to go right in the middle of it all and hope that in the middle I'm really, really close to where my in center would be. Once I locate the in center, it's not as easy as the circumscribe circle. There, just measure to a vertex, make your circle. Here, technically, I just measure to a side and make a circle, but to know how to measure to the side is the key. Quentin, I need to make a perpendicular. So I'm going to have to make a perpendicular to one of the sides. I usually just go with the baseline. So technically you could go with any side of the triangle. And in drawing that perpendicular, you're showing exactly where to measure to one side. Once you've got it though, yeah, just point on the in center and make your circle. Yeah, it's pretty close there. A little bit of a nudge on one side. Curious to see how we did. Wow, that's way off, isn't it? That bisector looks good. That one looks pretty good. This is the one I feel like is a little off. So let's remeasure here. Oh my, that's why it comes to slipping really bad. Let me see if I can tighten that screw up for you, because that thing is just a mess. I'll send your parents the bill for the service fee. Just kidding. Also, the pencil was a little loose in there too, so I tightened that as well for you.
Barely off.
Sounds like the guy at the car shop, right? Yeah, also change this out for you. I knew you'd want me to. I'm going to charge you an arm and a leg for it. Yeah, see how far off we were? And I think that's good. It's probably going to hit right about there, so it's still going to be a nudge off. That's a tiny bit off also, so yeah. Yeah, triangle in the middle shouldn't be that big. And you're looking at like, something's not right. Yeah, it wasn't. Oh, wow. Okay, so you can look at the arc and see how this little arc is small and that arc's big. That bisector didn't quite make it. So let's see where it should have been. Yeah, so we should have been down there more, which would have changed up quite a bit. What? Two perpendiculars there.
Yeah, it wasn't. This one I drew and it was wrong, so I redrew it and this is the line.
Now here, do you see how this line didn't actually go to the vertex?
Mm-hmm.
You've got to be more precise with that. Okay, that's going to mess you up. I feel like the bisection, so this arc looks a little smaller than that one. So I'm thinking maybe this should have ridden up there a little bit more, but this one was definitely offline. If it's offline here, it's going to translate to offline later as well. So yeah, just try to be a little bit more precise. I feel like the top one's off. Probably this point looks actually correct to me, and that would have shifted it over that little bit so it hits and hits. So again, just hard to be perfectly precise.
A little bit off.
All right. Go ahead and set that aside for now, though, and you're going to practice some more with these for homework. And take out a blank sheet of paper that's going to go in your notebook for construction 15. Construction 15. So top of a new sheet of paper, C-15. This is kind of an interesting one because we're going to construct not a circle, not an arc, but a segment of a circle. So that would be the portion of the circle bounded by
Two chords. Two radius.
a chord and its arc, right? So region bounded by chord and arc, that's what we're going to try to construct. Now you'll recall, before we get into this, you'll recall that we said that if you had some segment of a circle, you could inscribe literally an infinite number of angles within that segment. But we stated that all the angles inscribed within a segment would be equal. So what I'm going to give you is an angle that's inscribed and the size of the chord. And we're going to construct the segment itself. Okay, so here's our construction. Construct a segment of a circle. Construct a segment of a circle given the chord and the inscribed angle. Construct a segment of a circle given the chord and an inscribed angle. Where am I? Now, let's think for a moment. If I'm giving you the chord, and I'm giving you, say, the angle. Yes, sir.
Every angle is going to be equal.
They're all going to be equal, so it doesn't matter which angle it necessarily is either, does it?
Construct a segment of a circle. What do you like? What are we trying to like? I know we're shooting for a segment, but like.
So we're shooting for this.
What about that?
We're trying to construct it. So maybe it'll help if we go ahead and give ourselves a chord and an angle. Let's see. So go ahead and start, if you would, with a line, maybe a couple inches long or so. This will be our chord. And now here's the question. Do we want a major segment or a minor segment, class?
Minor.
Everyone's saying minor segment. So keep in mind, if you have a minor segment, what kind of angle will be in a minor segment?
Major. Or obtuse.
An obtuse angle. So you're going to have to give yourself an obtuse angle then, if you want a minor segment. If you go with an acute angle, you're going to give yourself a major segment. Okay, so and this is our inscribed angle. So we've got our chord and our inscribed angle. But think about this as far as how we might pull this construction off. If you have a bunch of angles you could put, right, and you have one set chord, you kind of have a whole bunch of possible triangles.
And you can inscribe a triangle in a circle.
And if I could come up with any triangle that includes this angle and that side, not a specific triangle, but any triangle with this angle and this opposite side, and then I have the triangle and I simply circumscribe a circle about that triangle, then I will have constructed the segment, wouldn't I? So that's what we're basically going to do. We're going to make a triangle that has this angle and this opposite side. Again, it's not one specific triangle. It could look a lot different, but regardless of how it looks, I mean, this would be a really weird looking one, wouldn't it? But it's still with that same angle, that same chord, and then to circumscribe the circle about it, we'll be good to go. So, bottom of the page, step number 1. Copy the given angle. Copy the given angle with long sides. Copy the given angle with long sides. So what I would suggest is start off with a long side. Oh, by the way, in parentheses, construction 3. I'm sorry. In parentheses, construction 3. Copying an angle. Thank you. I feel blessed. And bless all of you too, my children. Okay, I'm just kidding. We're not Catholic here. All right. All right. So anyway, long side number 1. Then remember, we got to make that arc on the given inscribed angle. Come to this end point, make another long sweeping arc. We gotta measure that angle's arc. And come over here and measure the angle's arc again. And again, when you connect the dots, make nice long sides. Reason being, we don't know how big we need these sides to be. So that's all step one. Step number two. There's 3 parts to it. It's kind of a compound sentence. Anyway, step number 2. Measure the chord, comma. Measure the chord, comma. Put the point of the compass a reasonable distance from the vertex, comma. Put the point of the compass a reasonable distance from the vertex, comma, and measure across the angle. Measure the chord, comma. Put the point of the compass a reasonable distance from the vertex, comma, and measure across the angle. So I've measured the chord with my compass. Now I need to put the point of the compass a reasonable distance from the vertex. Well, if I'm out here, am I going to be able to reach across the angle from here? No. But if I put it here, can I reach across the angle? Yeah. So a reasonable distance for me might put it right about here or so. So I'm going to put the point of my compass a reasonable distance from the vertex so that I can reach across the angle. We measure the chord, put the point of the compass a reasonable distance from the vertex, and measure across. Now, because I had an obtuse angle, I didn't need as long of sides as I may have with an acute angle, which we're going to look at in a moment when we practice. But step number 3, once you've picked a point, measured across and marked that, connect the dots to form a triangle. Step 3, connect the dots to form a triangle. Connect the dots to form a triangle. So here's my chord, and there's my inscribed angle. Now, I still have to put the rest of the circle around, or at least the arc that's going to finish off the segment. I know the arc is going to do something like this, correct? But I need to not just know about where it's going to be, I need to know exactly where it's going to be. So, step number 4, circumscribe a circle about the triangle. Step number 4, circumscribe a circle about the triangle, and in parentheses, C-12. Circumscribe a circle about the triangle, and in parentheses, C-12. Well, in construction 12, remember, we need to have at least 2 perpendicular bisectors. So I'm going to start by perpendicular bisecting the chord. And of course, that'll technically give me a diameter, wouldn't it? I don't see the circle yet, but I know there's a diameter there. And you realize technically, remember the picture? Chord, chord, chord. All the sides of my triangle are technically chords, aren't they? So if I perpendicularly bisect any other one of these sides, maybe my baseline, which doesn't need the compass open nearly as much, then I will find the center of my circle. Remember, for an obtuse triangle, the circumcenter will lie outside the triangle. So there's my circumcenter, perpendicularly bisects any two sides of the triangle. Now technically I don't need to draw the whole circle. Just need to measure to one of the vertices, and technically I only need to draw enough of the arc that would pass through the vertices. And so I have now constructed a segment of a circle given a chord and an inscribed angle.
Can you see step 5?
There wasn't a step 5. Step 4 was to circumscribe a circle about the triangle, C-12. Now again, technically I didn't, and if you want to make this little note, you technically don't need the whole circle. You only need enough of the circle to hit the ends of the chord. But it's not a problem to draw the whole circle either. Let's practice one more time, and this time let's give ourselves an acute angle. Let's practice this one more time, and this time we'll give ourselves an acute angle. Still give yourself a chord that's about 2 inches long or so. A little more, a little less is fine. Make it about 2 inches long. I wouldn't make it a teeny tiny acute angle either. I'd maybe do somewhere in the 60-degree range or so. And the first thing we're going to need to do, class, okay, good. We're going to have to start with a line, aren't we? Oh, a fairly long line. All right.
Copy the angle.
Copy the angle with long sides, which is why Genesis said to start with a long line. But yeah, we want to copy the angle with long sides. Alright, there's my inscribed angle. Or it's going to be inscribed once I get the rest of the arc around it. Alright, then what?
Measure the chord, put compass reasonable distance, and reach across.
Good. Measure the chord.
So that word for word.
Put the point of the compass some reasonable distance so I can measure across. This right here looks to be about a reasonable spot. So once you've found your reasonable spot, make a little mark where you're going to put it. And measure across.
Can you show that step one more time?
Yep. So I start by measuring the chord. Then I've got to put my compass somewhere so I can reach. Here I can't really reach very well. Almost I can reach. But right about here I was like, hey, this reaches pretty easily. If you want to go in closer may be better. It'll just kind of make your triangle start looking funny. But find a reasonable spot. It could be anywhere, remember. Because any angle with this chord is going to be in the same segment. So that's why you have the flexibility to put it wherever. There's some reasonable distance so you can measure across. Once I've measured that off, class, of course, we need to make the triangle by connecting the dots. And now we can clearly see our chord, and we can clearly see the inscribed angle. What we can't clearly see is the circle that makes that line a chord that would make that angle an inscribed angle. So how do we fit the circle there, class?
C12.
Construction 12. Circumscribe it. Circumscribing a circle requires you to
Get perpendicular bisectors.
perpendicular bisectors. A couple of them. And this time, for whatever reason, I have chosen to bisect the sides of the original angle. you're seeing arcs everywhere. The key is keeping track of which arcs are you interested in. So if you need to erase old arcs before you make new arcs, do so. And remember, for this, once you've found the circumcenter, you can circumscribe. Now here I did draw the entire circle. If I wanted to, I could go through, I suppose, and erase the part of the circle I don't care about. But here we see the segment. And it is obviously a major segment because I had an acute angle. Questions on construction 15. Yes,
how do we get this? How do we circumscribe the circle?
did you get your circumcenter yet? Your two perpendicular bisectors?
Oh no, I only have one. Okay.
Okay, so a second perpendicular bisector. And somehow that doesn't look like a bisector, Jamie.
Mine's messed
It's a
up.
perpendicular, but it's not a bisector. I feel like you picked a random spot. So remember for this, your compass is a little bit slippy as well. Maybe it's through all the use, all the compasses are starting to slip. There we go, that's better. So remember for the bisector one, arc, arc, go to the other end, arc, arc. So that's where the bisector should go. And you don't have to do that with another side.
Mine's messed up too.
Yours is messed up also. Well, so for sake of time, let's go ahead and just leave it where we're at. We do need to move on to construction 16. So, new sheet of paper, construction 16. Construction 16 is to construct a triangle given two sides. Construct a triangle given two sides and the angle opposite one side.
We can't do this proof if we didn't know how to do the other one, can we?
What?
We can't do this proof if we didn't know how to do the other one, can we? Like, I messed up on the other proof. Am I going to be able to do
On the other proof or the other construction?
other construction?
Yeah, this is a separate construction. Yeah. All right, so construction 16. Construct a triangle given two sides and the angle opposite one side. If you would go ahead and draw yourself two lines to be your two sides. Let's start with a shorter line and call it A. And let's draw a longer line, call it B. And we're going to be given the angle opposite one side. Now, for reference, if you have a triangle, you can call the three sides A, B, and C, right? And so if we want the angle opposite one side, remember here, angle A would be opposite A, B would be opposite B, and C would be opposite C. So the angle we draw needs to be either angle A or angle B so that it's opposite one of these two. We couldn't have angle C, it'd have to be A or B. Let's go ahead and draw an angle. Let's make it an acute angle. Go and make it angle, make it an acute angle. And let's call this acute angle, angle A. Let's give yourself a little side A, a big side B, and let's go with an acute angle, which we will call angle A. Step number one, as you go to the bottom of the page, is to draw a big long line. Go and draw a big long line.
So familiar.
Yeah, doesn't it? Now, I'm actually not going to put either A or B on this line. I'm going to start with the angle so that the sides end up opposite. So we're going to start step number 2 by copying the angle at one endpoint. Copy the angle at one endpoint, C-3.
Step 2.
This is step 2. Copy the angle at one endpoint. This is C-3. C-3. Again, good to make long sides since we're not sure what else is going on. Now keep in mind, if side A is the opposite, then side B has to be this one, because A is going to be here. So B is going to be the next one. So step number 3 is to mark off the non-opposite side. Mark off the non-opposite side on the new side of the angle. So the non-opposite here is going to be my side B. And we're going to mark it off here. So here is side B. That way side A will be opposite side angle A. So here's angle A, and then here's going to be side A across from it. Yes, ma'am?
Can you do that one more time?
Yeah, so we measure whichever side doesn't match. So in our case, side B, we'll go ahead and measure our side B, and we'll just mark it off here. If you wanted to, I suppose you could scribble off excess. We've done that in the past to help avoid confusion.
So step 3 is?
And then step 3 is going to be measure the opposite side. Excuse me, that was step 3 a minute ago. Mark off the non-opposite side onto the new side of the angle.
All right, so mark non-opposite side.
Right. And then step 4 is to measure the opposite side and measure across the angle to the base. Except it doesn't exactly seem to be working very well. I feel like my side A is too short. Anyone else having that problem? Yours is fine? So did you measure, so you measured off your side, oh, you need to extend this out a little bit so the side B can hit. Yeah, so just extend that out. That's fine for yours. Yours is too short too. Okay, and then you measured your side A. Oh, now that's interesting. Huh. Yours is too short? Yours is too short. Yours is too short like mine. Now, Quentin's is a little unusual. So let's do what Quentin did here just a little bit. Let's make our side A a little bit bigger. Because my side A just wasn't long enough, right? So let's make, not you, Quentin, but let's the rest of us make our side A a little bit bigger. Okay, maybe that'll work better. There we go. So now maybe when I measure my side A, oh, I'm like a centimeter too short. Okay, let's make it a little bit longer still. All right, so we'll make it a little bit longer still. That's the problem. I just needed my side A to be just about the same. See, now it'll reach, won't it? All right, so now we measure side A, side A 3.0. All right, and now this is what happened to Quentin. He, because now we need to just connect the dots, right? But does he connect these dots, or does he connect these dots? Yes, but he gets two different triangles. Did you notice before we started, I didn't prove this one?
Oh.
There's not a proof to this one. This is side angle. The thing that can't prove triangles congruent.
So this was.
Do you see now why it can't prove triangles congruent? You might not even get a triangle. You might get two triangles. How can the two triangles be congruent when one's a tiny little slip? No, you're not going to be quizzed on construction 16. But I wanted to show you why side angle can't work. By the way, I'm also not going to quiz you on construction 15.
So basically, you pulled a sneaky on us.
I did. So, but hopefully it's memorable. So tomorrow's construction quiz will have 3 constructions, but the only ones eligible for the quiz are 13, 14A, and 14B. So you actually know all 3 constructions that'll be on the quiz tomorrow. This will be the only time all year you'll know exactly what's coming on the quiz, but you do. Now, to help you, I'm going to have you do the next handout. I believe this is handout 6 if you're on YouTube. I want you to complete this handout this evening. You'll practice all 3 of these constructions. We'll go over it, and tomorrow you'll complete the same 3 constructions for your construction quiz. So, don't blow it and not get a free 100 tomorrow. All right, you are dismissed. Have a wonderful rest of your day.